Well, welcome again. This time with my other hat on. Last time it was the Fun Cube hat, and now I'm here with my ISIS hat, which is actually well, I'm now full-time employed by ISIS. I didn't found the company, but I was one of the first employees of the company. Actually, Wouter Jan, which you probably know, Papa Echo for Whiskey Juliet, who was here some colloquia back, and well, I don't know how long he has been attending already. Anyway, he started with a company with some other of the directors, but I have a slide on that as well. Some, well, small outline, general company presentation, who is ISIS, what are we doing, for those who do not yet know. Then I will focus on some of the RF systems we are using and developing at ISIS, and I have some example missions, FunCube being of course one of the missions we do. So first the company presentation. Well, as already said, ISIS was founded by Wouter Jan Ubbels and three other guys, Jeroen Rotteveel, Abe Bonnema and Eddie van Breukelen, as a spin-off of the Delphi C3 project. Decided to start a company, went also looking for employees, and while I was graduating on Delphi C3, they already approached me like, do you want to work for us? And well, I said yes, and I'm full-time employed. We've grown quite a lot. We're now 29 employees, of which 25 full-time equivalents. We have two offices now. The main office is in Delft. We just moved to a new building because we're all growing. And there's a second office in Noordwijk at the ASTEC facility of ESA, where we have a small office for every ESA versus ISIS business, where we have to consult ESA or have meetings or at least be there at the campus. There's also two other extra companies, but I'll first focus on ISIS as the main company, which we call ourselves the nanosatellite specialist. We do everything end to end. You can buy the whole package essentially if you like. To give you an example, if you have a science mission and you're a scientist and you do not like to think about satellite business but you just want data, then you can just give that to us and say, okay, I want the data, make a mission, create a mission for us and get me that data. And then you buy the whole package. But you can also just do everything in between. We're really flexible in that. So we sell small satellites, systems, components itself, platforms, which is essentially, the platform is the design of a satellite, in which you can add something of your own payload. We have launch services for auxiliary payloads, which is called piggyback launching. So all the cheap CubeSat launches, you can buy them via ISIS, and then we do all the contractual things with the launch provider. We do the qualification, if you like. So everything needed there. Then we have ground station and mission operations. That was one of my first developments, was actually a Genzo compatible ground station for universities. You can buy the whole package, and essentially you will get the whole ground station delivered at your doorstep, and then you can opt for the installation service or training, that kind of stuff. So it's a complete package deal. And the same, the last one, integrated space applications. That's indeed if you just have a function to perform in some way. Space might be the answer, and we can take care of that. This is not a real company as in a separate company, but it is one of the activities of ISIS, is CubeSatShop.com, which is actually the world's first CubeSat shop on the internet, in which you can actually buy multiple vendor systems. There's been other manufacturers with web shops of their own products, but we offer products from different companies. So we offer our own systems. We also offer systems of, for example, ClydeSpace, GomSpace, You might want to buy reaction wheels from another company. It's all on there, so you can essentially shop together a CubeSat on here. Well, Jim can tell you that it's not that simple yet. Well, we're working on that. At least the components are available through one site. Then we have Easy Launch. That's our launch branch, which we actually do all the contractual things with with a real launcher, like if you go on an Indian rocket, or you go with the ESA rocket or a Russian rocket. There's all kinds of negotiations and interfaces going on there, which you don't want to worry about if you're, for instance, in university. Well, you just want to launch, and you want to have your cube and hand it to someone and just get it up there and not have to worry about all the paperwork. So we take care of that as well. This is also a very interesting spin-off company, IDS, Innovative Data Solutions, which is actually, there's a hot item at the moment, which is AIS message tracking from space. So if a ship goes onto the ocean and runs out of range of a base station on the shore, then it's sort of lost. You cannot track it anymore. But if you do that from space, you can track it. And there's a lot of people interested in that, governments, insurance companies who want to know where all the ships are they are insuring. So there's a lot of interest there. There is, however, one big challenge, and that is if you look from a large height to Earth, you see a lot of area, and you see a lot of ships transmitting simultaneously, because they do know from each other, just like APRS protocol. They just listen on the air. Is there someone else? No, then I can transmit. But if those, well, it's a bit different, but the general idea is the same. If you're that high, then the two ships cannot know from each other that they're transmitting because they're too far away, but you see them transmitting at the same time. So you have to do something clever there to do something about it. There's a lot of new opportunities. The small enterprises and medium enterprises and agencies are starting to, get interested in CubeSats. Used to be universities. AMSAT is now building one. There's been the Japanese cubes, a lot of one-unit cubes from Japan, from universities there. But now also NASA and ESA are starting to get interested in CubeSats and build their own CubeSats, and also need systems for that. Companies, even large companies, are starting to qualify their space hardware on small satellites because it's cheaper. So there's a lot of interest, and for us, a lot of new opportunities to create products and to sell, basically. In my case, RF systems for such parties. RF systems is my main thing. I'm an RF engineer at ISIS. I do have a lot of experience with all the other parts, but that's because we're still a small company. So that's really fun to work with a lot of people in many disciplines. More about RF products and the roadmap. Some of you might have seen the antenna system already. It's also on FunCube, and we put one on display in the shop, which is at the moment the hottest item we are selling. The antenna system is only 6 millimeters high, so you can easily fit it on top of a CubeSat and have 4 deployable antennas. So they're stowed, and just like the Delphi C3 tape measure antenna system. We improved on that, made a new box, and that's really selling a lot, because it's antennas and deployment is really hard to do that in space and do it reliably. Well, we have successful deployment in space. There's now one satellite flying our antenna system successfully. It's a multidisciplinary team, which is also great. You get to work with mechanical guys, you get to work with the thermal guys, RF wise, of course, the antennas itself, but especially also the mechanical aspects. how to make an antenna unfold without it being catched or without a sharp edge cutting into something else. Or there's a lot to think about. It seems simple, but it's not. I already told something about the ground stations. Well, we offer an off-the-shelf solution for universities or companies, or well, if you want one, you can get one. It's a GANSO compatible setup that mainly is inspired on the Delphi C3 ground station, and the Delphi C3 ground station was also the example for the GANSO standard. So, well, the hardware there is, GANSO compatible. We provide training and installation options, so you can buy the hardware, but you can also buy the training, and then you can set up your own ground station and have your crew trained when a satellite passes over, that they actually know what to do. Very important, because in Delphi C3 we learned that the hard way. While we were acquiring the signal, we listened on during a wrong pass time, and there was some pointing issues and things were not going that smooth. So, well, we want to prevent that from happening for customers. We have at the moment VHF UHF S-band capability. Please note that everything in satellite business, apart from amateur radio, is in VHF UHF name-wise, so there's no 2 meters 77s. They won't know what you're talking about. S-band is also the big deal there, and they won't know what band it is. So, well, VHF UHF is actually done with a ICOM IC910 transceiver at the moment, but we're working on a software-defined ground station in which everything is flexible, and well, that's an ongoing development. And we have a lot of cooperation with the TU Delft. They still have the Delphi C3 ground station running. I'm the maintainer of the ground station, so if we want to try out something new, we can just go to the TU and try for ourselves before we sell the product to any customer. And we're also part of the GANSO pilot network test, but I'm replacing the GANSO talk, so I cannot say that the status of that, but well, we're in the testing phase. VHF UHF transceivers. This is the satellite side, so not the ground segment anymore, but what you put in space. We have a couple of products. The one being sold right now is the TRX UV, which is well, the VHF downlink UHF uplink transceiver, which is actually based on Delphi C3 heritage. It's a quite successful product. It also keeps the satellite coordinators happy, because VHF downlink UHF uplink satellite is what they really want. Unfortunately, we get a lot of queries the other way around. A lot of people want VU systems, but that will cause well, some problems, because there's not that much uplink space in the 2 meter band. So, well, we're proposing a new uplink sharing scheme, in which multiple satellites use the same uplink, but we still need to work on that, and I'll have a talk with Graham, of course, and the other satellite coordinators if it's a good idea. We always recommend the UV radios. Well, customers still want the VU. Please note that the range is not strictly amateur. You can also buy commercial frequencies. So the VHF downlink could also be 130 megahertz or something above the 2 meter band. You can also do the commercial frequencies with it. Next development in that line, in the VHF UHF line, will be the advanced ISIS transceiver payload on Delphi Next, the next satellite from the TU Delft, in which we will try a new PA, which is more efficient. We will probably try a new data protocol as well. And some other advantages and small improvements on the current system. So there's ongoing development there. Well, the interesting bit is S-band, because people need more bandwidth or more data, or higher data rates to get their data down, even from a CubeSat. They need more spectrum, and it's not available at the lower bands. Well, in 70 centimeters you could do it, but you take up a lot of bandwidth. Well, S-band is right now the band of interest where people want to transmit, and AO40 already did, so a lot of amateurs still have the gear lying around, so it would also be quite nice to actually have something there up again. So we are developing, or we almost finished developing the TXS, the transmitter for S-band. It's currently undergoing the last qualification test, so the design is almost finished. If the tests are okay, we can ship the first one out. It has 100 kilobits per second data rate capability, and higher data rates are under development. We also are creating a receiver right now. The first thing was actually because of the bandwidth limitations to have a transmitter on S-band. But yeah, receiver is the next logical step to also incorporate. And the S-band software-defined ground station, but that almost comes for free once you have the software-defined part sorted out, and you just add converters or additional radio hardware. So that's in the works. The AIS receiver, as already told, to detect ships from space. It's a cutting-edge receiver. I cannot tell you a lot about it yet. Maybe next year, because we are applying for patent for the receiver technology. It has some specially developed algorithms to sort out the overlapping transmissions you receive, and the receiver architecture itself is also quite new. And it hopefully outperforms our competitors, but we still have to see. We're launching 2 satellites to actually prove that. So hopefully soon we'll also have some AIS capable satellites out there. So yeah, that's a very interesting topic. Takes a lot of time to develop all the algorithm parts, and all the chip and the radio LNA part, the front end. That's nearly done, but yeah, we still need to work on the software part. Another interesting thing, it has been a buzzword around all industry on Earth. So not space-based wireless sensor networks, but factories, or that you just place a sensor somewhere on a machine or a component and have it wirelessly linked to your network, and that you can actually use that to reduce a lot of cabling. Well, in space the same is happening, but of course, since they're quite conservative, it's even harder to get that to work in space. So yeah, it's a novel idea to save a lot of cabling harness, so a lot of mass, and you can attach sensors on difficult places, which is also quite interesting. For instance, if you have a very long deployable antenna, on the end, if you place a large mass and you have a cable running past your antenna, you will not only have a lot of EMC problems, you also have the extra mass of that cable on that very long stretch. And it would be much easier if you could just plant the sensor at the end, have a small solar panel to power the sensor, and have it wirelessly talk to your onboard computer or data handling system. So yeah, ESA is also very interested in this, and yeah, we're teaming up with them to develop something for that. Some of the example missions. We have the educational mission FunCube. Well, there's been a lot of talk about that. This presentation was given for non-amateurs. So yeah, actually everything is, I think, known. What should be noted is that AMSAT-UK makes the payload. So I'm designing the RF board with my personal non-ISIS AMSAT hat on. And at the same time, at ISIS, I'm also working on the other various bits we have to provide as a company. So it's a two-hat system for me. Yeah, so that's one of the running missions at ISIS, and where we actually expecting flight hardware to be in the clean room pretty soon. We have a new clean room in our new building, so hopefully FunCube will be one of the first to actually be there. I already mentioned Delphi Next, which is the next satellite after Delphi C3. That's a new, the new satellite. I think there was already last year or the year before a talk about Next. I'm not completely sure anymore. It changed quite a bit. They had to change some of the payloads, change the configuration a bit. Well, still work in progress, of course. So, yeah, there's a lot of change. But the latest status is actually that it will be a technology demonstration for various RF systems. Our new transmitter for VHF UHF. There might even be an S-band link on there for them. Propulsion module from TNO, a small cold gas propulsion module. Some detector technology from Cosine Research, is also a Dutch company. And some new power system technology from the TU Delft, Systematic, which is a chip making company which was founded by one of the graduates of the TU. Well, one of the other things we're quite busy right now with is setting up workshops, courses, and various other training programs for knowledge transfer and training, because a lot of customers ask that from us. They're coming to us, can we buy a satellite, and can you teach us how to do it in the future, because we want to buy one satellite and then we want to build our own. A lot of universities want a jump start for a CubeSat program, so they have the money, they have the people available, but they don't have the knowledge. So at first they want to buy a satellite, get it up in the air like a sort of flag, like the Americans planted on the moon. We want to have a satellite doing bleep, don't care what it actually does for the rest. At least it should contain something like a reference to our country and our university that we can do it, and then they just buy that. And after that they really want to make CubeSats, so they also want the training. Well, there's a lot of time to be invested in making good class material and training material. So if people around here ever done that, making material for teaching, you know that you at least need a couple of years to just see what people do know and don't know, and what's difficult and what's easy, because for us everything seems logical and well. Okay, partners and clients in this. The Delft University is a partner and a client. They are providing us with some courses, but they're also taking our courses because with our company we have a slightly different customer base, so different insights. Cape Town University, DLR, big institute in Germany. Well, SSTL is on there to be confirmed, so hopefully soon to be confirmed, and ESA as well. So the training part, that's also quite interesting business. Science missions, like I said, NASA AIMS is making the satellites smaller and smaller. It's an agency who used to have millions of dollars to spend on big satellites. ESA, by the way, same story. All those satellites are pretty big, getting smaller and smaller and smaller every time. And they're now into CubeSats. So it's quite interesting that they do science in such a small envelope, and you can do a lot with a CubeSat, which is essentially, if you go and look at it and all the challenges, it's really small. But fortunately you can buy a lot of commercial off-the-shelf products right now, so they can have a jump start as well and focus on the science part, and let someone else handle the other difficulties. I think there's also going to be a presentation about QB50 tomorrow, if I'm correct, but I'm not in on that part of the company. But if I'm correct, we are going to be one of the suppliers for QB50 for the hardware. So that means that we will supply parts for the QB50 satellite initiative, and that's going to be 50 CubeSats. So that's a nice market if you can be a partner of that. So yeah, we are a partner of the QB50 project. So more on that tomorrow, I think. And the last one, radio astronomy, and I have a slide on that as well. ALFAR, which is actually I I don't know if LOFAR around here is a famous project, but it's in Holland and partially in Germany. They have put up lots of phased array antennas to actually listen to low frequencies. Well, because there are a lot of interesting things happening in space on low frequencies. The thing is, not only is our environment here electrically polluted on low frequencies, and then you should think of 30 megahertz and lower, so HF bands. Well, everybody knows that it's quite noisy there. But also our Earth itself, or at least the layers around the Earth, are shielding us from that low frequencies quite a bit. So yeah, there's going to be a orbiting telescope actually, using small satellites, which will receive on low frequencies, and all the correlations must be done in space. There's inter-satellite links for the satellites to communicate. They're going to orbit around the moon, because if they're behind the moon on the other side, they're shielded by the moon from the Earth's disturbances and all our interference. So that's quite challenging. And they want to do formation flying alike things as well. So yeah, it's basically a huge phased array, but then behind the moon, made of small CubeSats. So that's the real challenge. And well, if we're succeeding in building this, we'll probably be able to investigate the first section of time after the Big Bang, which is now well, sort of unknown territory, because we cannot detect the signals because they go so low in frequency. It's actually a Doppler effect, but then so intense because the expansion of the universe, that speed produces a lot of Doppler, and signals that were light at the time of the Big Bang are now VLF sub-kilohertz waves. So if you want to measure that kind of old phenomena, you really have to go low, and this is the way to do it. For the questions. That was the last slide. So are there any questions?
Questions? The low frequency VLF phased array antenna, they've put one up at Chilbolton, which is a telescope space observatory thing.
Could you repeat the name?
Chilbolton.
Yeah.
Which is near Winchester.
Okay. The VLF reception.
Yes, and it's part of the European thing. But
yeah,
apparently they had severe trouble with rabbits chewing the cables.
Okay, so it's not only electric interference.
No, it's not only electric interference, yeah. Rabbits.
Yeah.
Well, they showed us the damage.
Yes, a question from Richard, G3RWL, who is not here in his shorts today, which is a relief, I suppose, for some of us. His question is how, I think this is in relation to ISIS, how are they handling ITAR with US customers? Or I'm not sure he's got that the right way round.
Well, but, it's a very good question. How are we handling ITAR with US customers? Essentially, what it comes down to is that you have to have something like a web shop where you can order available components without questions being asked. Because they can order our radios, but they cannot tell you anything about their specific needs. So you really need to put something on there which they want to buy, and then you ship it to the US, and if there's something wrong with it, and it needs to go back for warranty or something, you're out of luck. They cannot send it back. So you need to send a second unit. So it's a kind of one-way traffic. So ITAR is handled in such a way that ITAR is really a large trouble for us. Also with getting components from the US, by the way, to put on our products. But if people want to buy our products, it's a one-way deal essentially. Just we ship something out and then it stays in the US, and we don't know something if anything happen to it. They cannot even tell us that it doesn't work. Because then we have to ask, what did you do to it? And they cannot give us that information. So it's quite difficult. But yes, we did ship a couple of units to the US. So there's customers prepared to do that. Now the ITOR expert.
I'm not an ITOR expert. This is a big thing. What percentage of your customers are using amateur radio frequencies for their satellites versus commercial or military frequencies?
I think it's because our customers are mainly universities right now. It's something like 80% of amateur. But there's also a lot of classroom satellites. So you actually you just don't produce a flight board, but an engineering model. And we expect that those customers also apply for frequency coordination in the future and will be a fully functional CubeSat. But they are now in the classroom state where they have our radio in a CubeSat just for demonstration purposes. So yeah, something like that.
80%. Okay.
Any more questions? Well, thank you very much indeed, Wouter,
You're very
for
welcome.
filling in.
Yeah.